problem is called average of levels in binary tree. We are given the root of a binary tree and we have to return average value of nodes at each level in the form of an array. Answer return 10 to the -5th of the actual answer will be accepted. So there's like a small margin for errors because of the rounding up when calculating the average. So as you can see here, for the first level we have number 3. So for the first level basically the average will be 3. For the second level, we have 9 plus 20, which is 29, and because we have two elements, we basically divide by 2, and the average will be 14.5. For the last element, for the last level, we have 15 and 7, which they add up to 22, and 22 divided by 2 is 11. The same goes for the second example. We just have basically switch the nodes in the last level to be in the left subtree of the whole tree. Now the number of nodes in the tree is in the range 1 to 10 to the 5th, and the node values is in the range of the integer, minimal and maximum integer. Now to solve this problem, basically it's like we have to know how to traverse the binary tree level by level. So level traversal it's done by using an algorithm called BFS, breadth first search, and we will see how it behaves when performed on a binary tree. So BFS data structure that we are always using is queue. We basically start by initializing the queue with the root element, and in our case is basically 3. Then we will iterate over the queue until we don't have any elements left. For each iteration, we will check what's the current size of the queue, and we will pop all the elements that we have inside the queue. But after we pop the element, we check if it has left or right children nodes, and if it has, we will add it to the queue so that those represent the next level. And basically, by using that logic, we will get a level 3-level traversal. So we start with 3, so we will just pop the number 3 from the row, and we will basically calculate. We will just keep on adding it while iterating over the queue. Keep on adding the number to the sum, and then after we are done, we will just divide by the initial number of elements inside the queue to get the average. So because we have only one element and the sum will be 3 divided by 1, we will have only 3, which will add to the list of the average values inside the tree. Now, for when we pop the number 3 from the queue, we will add its left and right children. So in this case, we will have 9 and 20. And for those, we will just keep on adding them to the sum. So we will have first 9 and then 20. So the sum will be 29. And we will have 2 elements. So we will divide by 2 and we'll have 14.5, which will add to the list of averages. Now, when we pop an element from the queue, we will check its left and right node. For example, element 9 doesn't have a left or right node, so we will not insert anything, but the node 20 has both left and right, so we will just add 15 and 7 to the queue. Then we will iterate over these numbers and we will add them. We will get 22, and divided by 2 we will get 11, which will add to the averages in our list that we will return as the final result. Now, for both of the elements, we will pop them, and we will see that they are leaf nodes, and they don't have either left or right children, which basically means that in the next iteration, our queue will be empty. And because it's empty, the algorithm terminates, it completes, and we just basically return the list of the averages. Because we have a special data structure for this, our time complexity will be n, which is basically the number of elements inside the tree, and the same goes, because of the data structure, the same goes for the space complexity. We'll have a total n number of nodes inside the queue. So we are given a class 3 node, which basically just contains the value and the left and right children and some constructors to initialize the tree node. We will declare our queue, which will be holding the 3 nodes that we are iterating over. And we will declare also our result, which will be a list of tuples, because by the problem statement we have to return the averages will be double in a double type. Next, we will add the root to our queue to start it, iterating over the nodes, and we will iterate as long as we have elements in the queue. Each time we will first check what's the current size of the queue, and we will declare our sum to be 0. And as long as we have elements, so we will iterate over all the elements using the number of elements and decrementing it each time. We will pull for each iteration. We will pull the current front element at the queue, and we will add the value of that node to the sum, and we will check if its left node is defined. If it is, we will add it to the queue so it can become the next level, basically, of our iteration. We do the same for the right node. We just add it if it's defined. At the end of the iteration, we just divide the sum by the initial size of the queue and add basically that represents our average of the level, and we just add it to the result. Finally, we just return the result, which represent the list of averages per level of the binary tree.